Hello everyone, we're gonna do a few tests. The point of this tutorial is not about doing the math in this test, it's just to show you that everything has a repeatable pattern in this test. So we're hopefully gonna manage to do 2 tests, although that's pretty unrealistic in 3 hours. And stop me whenever you have a question, don't worry about it. Or if you think all the math on the board is redundant because it's just math, tell me and we'll skip ahead a little bit. Finally, while I am the tutorial teacher, I'm not God, I might have mistakes. So if you find a mistake, just tell me and I'll fix it in the tutorial and upload it after class. Alright. So we start with the 22A, question 1. Q1 is always Euler-Lagrange. Okay, so they're giving us some. First of all, we write Efrat likes to give a question that has some theoretical background, some actual background in physics. You don't need to know this background. You first of all just write down the details that she gives you. First of all, the Lagrangian. They give us the Lagrangian square. 1, 2. Copper.
Usually it's enough to work with the with only the density, right?
What?
You usually only need to work with the Lagrangian density.
Yeah.
Correct? Or?
Usually yes. Usually the reason why we write the full Lagrangian is because we'll always do Fourier transform, and it's important to remember the integration to it.
Couldn't you do the Fourier transform like discrete?
Yeah, but then you'll have the exponent remaining. I don't like it. I don't want it. Right. So it's gamma Phi1 minus Phi2 power 4. I missed the square here. Alright. So the first thing that she gave us the Lagrangian. Second thing, the fields are real functions. That's the second detail, right below it. And all the constants, I'm gonna write it down. A positive constant. So now, for the first segment, she asks us to get the Euler-Lagrange equation for Phi1 and Phi2. I'm gonna do Phi1, and then I'll assume you'll be able to do Phi2 yourself. Okay, so talking about Phi1. For the Euler-Lagrange equation, we need 3 terms. It will be the derivative of the Lagrangian density for Phi, the derivative by Phi1 minus derivative of t of Lagrangian density, the derivative of the time derivative of Phi1. Notice that this this term in our parentheses is our new variable that we derived by. It's like an independent variable, and then it's a bit of a legal writing, but I like to write it like that. Note that there is no such thing. It's ill-defined to derive by a vector, but this entire form basically means take the derivative of x derived by x plus the derivative of y. It's basically a short way to write all the three, or in this case, two special terms. It's just a quick way. No, this is just notation. Okay, so now we do each term independently. 1 equals, okay, first of all, the first term have no direct dependency on phi1. Second term is just 2 times alpha, phi1 plus phi2. Third term minus beta phi2. Yep. And then the last term minus 4 gamma phi1 minus phi2 power 3. And I use the definition g of x x equals d g of x dx times d f d g of x. This is a known relation, derivation. I just used it to simplify, for example, so I wouldn't need to open this power. Alright, so now the derivative in time. Right here, so it's 2 kappa dot t squared phi1 and phi1 is very similar, minus 2 kappa u squared phi1, which of course usually we just write it like so. I forgot the name. It's a kernel, right? I always forget the name for these symbols. It's fine. Okay.
So the absolute value of the gradient, you don't really need it, right?
The absolute value here is to indicate that there's a vectorial multiplication. Of course, you can write a conjugate on your field function, but it's real, so it's meaningless. All right. So putting this all together, just add this minus the 2 derivative, 2 alpha by 1 plus 2 minus beta phi 2 is 4 gamma by 1 minus phi 2 to the third minus 2 kappa t squared phi 1 plus, because it's a minus plus 2 kappa squared something squared phi 1 equals to 0. Alright, similarly you can find the equation for phi 2, but since we're not going to use the 1, 2 index for the rest of the question, I'm not going to write it. I'm not even going to write the final result because it's irrelevant. Alright, now, after we done that, Fred asked us to use the two Euler-Lagrange equation to find a representative to redefine them using phi minus equals 1 over square root of 2 phi1 minus 2 and phi plus equals 1 over square root of 2 phi1 plus 2. Okay. Technically, in the question, she asked to transform the Euler-Lagrange equation using these conditions and then transform the Lagrangian. But since we're going to do both, I'm going to do something that I think is simpler, which is first transform the Lagrangian and then find again the Euler-Lagrange equation for the phi plus phi minus. Basically, as I'm trying to say, the fact that the frat asks for a certain order, it's not holy. Just do it in the order that makes sense to you.
Is this before the gamma alpha or 4?
4.
Ah, okay.
Yeah. My famous writing. Okay, so I'm gonna erase everything here. I'm just gonna leave the Lagrangian itself because I want to transform it. We have some simple terms to transform. For example, this one is clearly just phi plus, this one is clearly just phi minus, but there are less trivial terms. For example, this term right here. So for them, I'd like to write some simple translation table. And the two, when you have this sort of plus minus relation, the two special cases that pop to mind is phi plus dagger plus phi minus dagger, phi minus squared, phi plus squared plus phi minus squared, and phi plus squared minus phi minus squared. Let's see what each of them will give us. First of all, there's 1 over 2 on the outside, and then phi1 dagger plus 2 phi1 phi2 plus phi2 squared plus phi1 squared minus 2 1 phi2 plus phi2 squared. We just be equal, you can clearly see it's equal to phi1 squared plus phi2 squared. And the difference between them, if you take a difference, phi1 squared plus 2 phi1 phi2 plus phi2 squared minus phi1 squared plus 2 phi1 phi2 minus phi2 squared equals 2 phi1 phi2. Okay, so we found this term, this annoying term. The only terms left are the terms right here. But notice that if I write instead of phi plus squared plus phi minus squared, I'll write dt phi plus squared plus phi dt phi minus squared. Doing the exact same calculation, I'll reach dt phi 1 squared plus dt phi minus squared. Probably should have just written it on the other board. My point is that combining here the derivative in time of 1 and the derivative in time of 2 will be just like the combining the actual function and transform here. So the first sum here, the only thing that needs to change is changing 1 and 2 to plus and minus using this relation. And this term right here will have a differential relation to the plus and minus terms. So let's write it all again. And the plus and minus terms. Again, L equal sum over the integral d squared r, sum over j equals plus minus of dt j squared minus u squared value j squared plus alpha phi plus squared minus beta divided by 2, because there's 2 here, minus beta divided by 2, phi plus squared minus phi minus squared. Right? And then the last term minus gamma phi minus the power of 4 divided by 4. Divided by 4. Actually multiplied by 4, sorry. Multiplied by 4. Since I erased. Everyone understand how I got this equation? Alright, good. Now I'm not going to write it explicitly, but I think it's pretty obvious how to separate it to plus and minus terms. There are no cross terms here. See, all the terms are separated. I'm not going to write it explicitly, it's a waste of time. And now they said, okay, find the Euler-Lagrange equation, and they claim that there is a uniform solution for phi plus minus, which means phi plus minus t equals phi minus 0. Which phi plus minus 0 just means a constant. They assume that they claim that there's a uniform solution for the Euler-Lagrange equation in this representation. So let's find the Euler-Lagrange equation and put in a constant. All right. So phi plus do plus equals 2 alpha plus minus beta plus, right? Then the t of the t phi plus just be equal to just make sure I'm not doing any mistakes. Yeah. 2 kappa d squared phi plus and the Lagrangian equal to 2 minus 2 kappa u squared plus. So so the final result for phi plus and phi minus, I'm not going to write the full development of phi minus. For phi plus, it's 4. I miss a 2. Where did I write 4? I miss a 2 here. 1 second. Oh yeah, I missed a 2 here. Since, okay, that's why you should work organized. So, mind you, phi plus is equal to square root of 2, phi 1 plus phi 2. So there's a square root of 2 missing here. So it's times 2 over here. So over here it becomes a times 4. Again, as I said before, not perfect, make some mistakes, and we're trying to get to finish a lot of questions, so I'm trying to move fast. Square Similarly, I can do the same thing to the minus and get the result of beta v minus minus 16 gamma 3 minus cubed minus 2 kappa dt phi minus u squared phi minus. Right. Also, I would like to mention that the full calculation is already uploaded to the website. So, if you want to see the steps, you can just open Let Me Down on your phone, your tablet, or computer, and see them explicitly. All right. So, the FAT claims that there is a uniform solution. I just put the solution in. Since we're talking about a uniform solution, the derivative term cancels out, and we're only left with 4 alpha plus 0 minus beta plus 0. Okay. Beta v minus 0 minus 16 alpha v minus 0 equals to 0. Now we note that the FRAT told us that this non-trivial constant solution is only correct for alpha equals beta, and we can see it directly from the condition on equation 1. If if beta is not equal to 4 alpha, the only way the first equation will zero out will be if phi plus 0 will be equal to 0, which is a trivial constant solution, and she specifically asked. Okay, she didn't specifically say non-trivial, but when she says uniform solution, she means not trivial. She just didn't write it. And we should watch for it. So, phi plus equals 0 if beta not equals 4 alpha, which is what we look for, and so this is what is cubed. And phi minus 0, the non-trivial solution of it would be 1 over 4 square root beta divided by gamma, 1 over 4. We're specifically looking for non-trivial solutions, so I'm ignoring the solution of phi minus equals 0 and phi plus equals 0. That was part 1. Now, for B, if I asked find the plus, the minus, and then find the Hamiltonian of phi plus, phi minus, phi minus. When focusing, beta equals 4 alpha. Okay. And the final part of this question about using the approximation we insert after we found the Hamiltonian. That's what I did. Okay. So first of all, let's look when beta is equal to 4 alpha, we see that the plus term here and the plus term here cancel each other out. So there's no plus term, there's only minus terms on the constant. And we're only left to find the Hamiltonian we know that it's equal to sum of j, pi j dt j, minus Lagrangian. Technically, what I wrote here is the Hamiltonian density. Again, it's fine. Okay. So we need to find the pi's. If you remember, conjugate momentum is defined as the derivative of the Lagrangian density by the time derivative of the function. Right? So we know here, time derivative of the function, just 2. Am I missing a kappa there?
Yes.
Oh no. Thank you. It's 2 kappa gt of phi. And then notice that this equation is correct for both j, so I'm just going to put the conjugate momentum of j. Right? And when and note that multiplying this the conjugate momentum by the time derivative of the function will just give us the same term as the Lagrangian, but times 2. So the Hamiltonian will just be integral d squared r sum over j equals plus minus kappa t j squared plus, this time it's plus because it's minus minus, spatial derivative squared plus beta divided by 2 phi minus squared plus 4 gamma phi minus to the power of 4. Which of course I'm going to replace this beta with a 2 alpha just to keep, and then obviously I need to count my minuses because minus minus is plus and another minus minus. So again, minor mistake. Obviously I should stick to my notes. Okay. So we found the Hamiltonian, and now we're given the solution, an approximate solution for phi plus and phi minus.
Is it okay to leave the Hamiltonian in terms of the time derivative of phi? Should we change it to phi?
Technically, we should change it to pi. I'm just leaving it here for a second, just to make a point about the approximation. I'm gonna write the replacement in a second. Okay, so we're given phi plus minus equals phi plus minus wave plus phi minus 0. Basically, we're telling us, Tworet is telling us that the solution for the field is a constant plus some small change, which we only keep the second derivative. So, first of all, in the derivative terms, the constant will vanish. It will be just as simple as adding a wave here. And we'll note that the conjugate momentum will also must be replaced in a wave.
So, why did you put plus instead of minus?
Where?
In the test I see that she said that it's with minus the constant.
Okay. Note that I changed I moved the constant to the other side of the equation because I want to replace this wave function, not this wave function. Okay, so writing all the replacement. On. And now, since I know that the approximation of pi goes the same as the approximation of phi, I'll replace this term with the pi. So we'll have 1 divided by 4 kappa pi approximated j squared plus u squared kappa approximated minus 2 minus 2 alpha. I skipped the yeah. Minus 2 alpha phi wave squared minus 4 alpha phi squared phi minus 0 not squared minus 2 alpha phi 0 squared. And then the quadratic term, I can fully open it and then remove all the terms that are over the second order, but I'll just use the Newton binom to take the only the relevant terms, which I already know are the terms that are second order or less. So it'll be plus 24 gamma phi minus squared phi 0 squared minus plus 16 gamma phi minus squiggle phi minus 0 cubed plus 4 gamma phi minus 0 power 4. Okay? And now, since I'm cold-hearted and so mean, I'm gonna just take out the constant. I don't care. I don't care about constant in my Newtonian. Alright? And we also know that using the solution we achieved in A, the phi minus constant is equal 1 over half square root. Did I say half or did I say 4? 1 over 4. Alright, this is a mistake in my note. Let me just, I'm not going to fix it now, but I'm going to write it to myself. This is a mistake. 4, okay. So 1 over 4 alpha divided by gamma. Just then. Oh no. It's 1, okay. In my notes I didn't do it organized, here I'll do it organized. 1 over 4 beta divided by gamma, but I'm working here with alpha. I decided earlier that I work with alpha. So beta is equal for alpha. 2 goes out, so it's 1 over 2 square root of alpha divided by gamma. Alright? This relation there gives us condition 4 minus 4 alpha 0 of the approximate function 0, which is this term, plus 16 gamma phi minus 0 cubed equals 2 minus 2 alpha square root of alpha divided by square root of gamma plus 2 gamma alpha square root of alpha divided by gamma square root of gamma phi of this is phi minus squiggle. Right, I just put in description. Of course, I think you can quickly see that this thing is equal to 0. Right? Now, I can also put this equation up in this term, so this term is removed, and this term is removed, so I can also put it here. And to save you all some time, I'm just going to write the final solution. H is equal, I'll add here the time derivative, just for convenience later. It's minus 1 over 4 kappa squared plus u squared kappa squared is 4 alpha 3 minus squared. That's all we have left. That's all we're left with. Okay, and now the most important part that I wanted to present, part C of the question. Okay, this is the Hamiltonian, and in part C, you want to do two simple steps. First of all, Fourier transform. Second of all, you want to find a simple form for the Hamiltonian using the creation and annihilation operators. Okay, this section is again, I don't want to say stupidly, but stupidly looking at the equation and just putting in non-transformations and letting everything sort itself out. So first of all, let's remind ourselves for a second that pi j and phi j, I'm not going to write the squiggle. I probably missed one and then everyone will get confused. For now, I'm going to rewrite our function as just phi j without the squiggle. They're both real, because they're made up of real functions. Alright? So, when we talk about Fourier transform of this function, for example, k, for example for phi, we need to remember this equation the Fourier transform of a real function is I'm pretty sure it's called symmetrical conjugate. Don't check me. I might be wrong. But it simply means that if you flip the index, it will be the conjugate. So phi of k is equal to phi of minus k conjugate. It will be important soon. And now you want to take each of these terms, and Fourier transform them. I'm going to transform only this term, and I'll count on you to transform the rest yourself. Alright? So, first of all, we need to define our transformation. So phi j will be equal sum over q. Note that q is an index that has special component and a time component, and technically a frequency component. Phi j q times e to the I q r minus omega n tau. Right? And now you should also note, it's very important, that the transformation of j, of the pi of the conjugate momentum, the canonical momentum, equals pi j q e to the minus pi q r minus omega n tau. Note, there's two things to note here. First of all, no matter what convention you use for phi j, it should be the offset for pi j, minus, plus. And the second, more important thing, I lied to you here, there's also a normalization factor, which I always ignore. Always ignore. I don't care. I'm never gonna write it, I'm never gonna learn what it is, I don't want it. Okay, so let's try to transform just phi minus squared. Alright, so integral d tau d squared r phi minus squared, ignore the constant for a second, equals integral d tau d squared r sum over q tag, since we have two functions, phi of q tag, e to the I q plus q tag r cos of this vector minus, sorry for how tight this is, right? I hope everyone understands this, because this is just simple for you. Okay, so this integral doesn't have this two function doesn't have any dependency on tau and r, the function in frequency. So we can take this integral all the way inside before the exponent. So this is equal sum over q tag phi q tag integral tau integral d squared r e to I q plus q tag r minus omega n plus tag tau, which of course you all already know. This one is equal delta q minus q tag. You know this. I'll look at you. Alright, so over q, phi minus q, I intentionally wrote it minus then plus, because using the relation right here, will be equal sum over q, phi q conjugate, technically conjugate you write it like so, wave function equals sum over q and phi q absolute value squared. Right? Just note a little tiny thing. Sometimes I'll use the line above the function, and sometimes I'll use the conjugate. Technically, conjugate is for operator, for matrix, and stuff like that, and the line is for field or for function, something like that. So it's more correct to write a line, but no one's gonna do anything if you will just use a conjugate, a dagger, wherever you want. It's fine. Okay, so this exact transformation we can do for the pi term, and we can do for the delta term. I'm not gonna do it. I'm just gonna note that delta phi j will be equal sum over q I q phi q e to the I q r minus tau omega. Okay. Right? The derivative just reduces and the escape vector. Okay, so this Hamiltonian transforms in the end to h equals sum over q 1 divided by 4 kappa pi j q value squared plus u squared kappa q value squared j q squared plus 4 alpha value phi minus q squared. Okay. So we see that we got the function, and now after we got the full and organized picture in the Fourier transform space, we need to transform this wave function into operators. How do we do this? Well, there's one transformation that is correct for, I want to say 100%, but I can't guarantee it, so I'll say 99%. And we use this simple transformation, Vj psi q equals square root of a by square root of 2, a j q dagger plus a j q. OC, I don't remember if she said it's boson or fermion, but it's the same. Sorry. 1 divided by square root of 2a ajq dagger minus ajq. Right. So this is a transformation you should remember by heart. It's very useful. And the point of it is that we have square terms of this operator. So you'll have both a combination of creation and annihilation, and you'll have terms with squared creation or squared annihilation. And we don't want this term, this mixed, non-mixed term technically. So in the top here, there will be with a plus, since there's a plus in the middle, and when you take the pi squared, there will be those double terms will be with a minus. And then we can change the a so that these annihilation or creation terms will cancel out. Let me just show it on the board, and then it will probably be a bit clearer. Alright, so h equal sum over q 1 divided by 8 kappa a. One more thing. Sometimes you'll see this this transformation using an a instead of the square root of a. I think using the square root of a will be much simpler, since you won't have a term here which is squared, then just be a little bit earlier. So I'll use square root of a instead of a. Alright, so first of all, it's pi ajq dagger minus ajq, and then pi conjugated. So ajq minus ajq dagger plus.
Shouldn't there be an I somewhere in the definitions of phi j and pi j?
Technically, there might be representation that would have an I. If that's the case, you'll see it in your
first
A.
one?
No, you'll see it in. You can also see it inside the A.
Oh,
I just use this definition, so I don't want to confuse anyone by maybe making a mistake.
If you don't put an I near one of the annihilation operator, then phi and pi are not omission operator.
yeah, it's not omission.
If you dagger phi,
It needs to be I over
Over
square
the-
root of
yeah.
2a.
Right.
אבל השדה פה הוא ממשי.
I mean, you're probably right, and I probably forgot it, but it also works like this, but let's put an I here and solve it again. I solved it without an I and it came out fine.
זה לא צריך להיות אמיתי.
הספר.
If someone wants to quickly calculate this and come back to us, it would be really good. But for now, I'm gonna solve it how I solved it in my notebook, and at worst I'll change it and upload it today, the fixed solution. But for now we'll do it maybe wrong. Okay. So, A, U, kappa. Oh, there's actually a second answer to this question. The solution for this conjugation relation is also up to your presentation. But that's going way back into basic quantum. Anyway, let's move forward for now. Divided by 2, again, EJ Q W plus EJ Q, EJ Q plus AJ Q dagger plus A for alpha divided by 2, A minus dagger Q plus A minus Q, A minus Q plus A minus Q dagger. Okay. Now, instead of opening this entire equation and doing a very log and ugly calculation, we know that this constant should be equal to this two, or at least to these two together when it's minus, or and dash this one when it's plus. So let's try to focus on finding the A, and then later we'll write the Newtonian presentation. So if J equals minus, we know that A 8 kappa A is equal to A U, and it should be U squared. No, I did write a U squared. U squared. In my note it was U squared. Okay. A U squared kappa Q absolute value squared divided by 2 plus A for alpha divided by 2. This is just a quadratic equation, so the simple solution would be A equals square root of 1 divided by 4 kappa U squared kappa Q absolute value squared plus 4 alpha. Similarly, for J equals plus, I separated the cases because in J equals plus we don't have this term. 1 divided by 8 kappa A equals A U squared kappa Q value squared divided by 2, or A equals square root of 1 over 4 kappa squared U Q U squared. Alright. Okay. Now, Fra told us that we want to achieve an Hamiltonian equals sum over Q J omega QJ EQJ dagger EQJ. Okay. And we know that if we input A back into either of these terms, we'll get the same term before the multiplication, and that will be omega. So omega will be twice A inserted here, which will give us, where is it? Omega minus Q equals square root kappa U squared, which is value Q squared, plus 4 alpha divided by 4 kappa, and omega plus Q will be equal square root of U, no, actually U, so value Q divided by 2. I got this from inserting a solution, inserting a solution back into the first constant and multiplying by 2. Right, this was the first question. I can write the Hamiltonian using the omegas, but I think it's redundant. Let's write it again. And of course, if I have a dagger, I switch the order, I'll have some constant attached to it. Again, I don't care about constants. They don't speak to me. So, you want like 5 minutes, or like should we jump straight into question 2? It's up to you.
Depends on you.
I'm here for you. No opinions?
Jump 5 minutes.
I think we'll.
5 minutes? No?
מישהו רוצה 5 דקות?
Oh, very opinionated. I can barely hear myself think. Alright, so I'll erase the board and we'll start question 2. And then we'll just take like 10 minutes after we finish the test. Well, let's do a little bit of summation for this section, for section question 1. Just a tiny bit. Okay. Now, a little bit of summation. First of all, 1. We will always be given some Lagrangian, and you just usually most of the time the first equation, the first part of the question will just be putting it into the Euler Lagrange equation. There's not much to talk there. It's just simple calculation, and there might be a little bit of a trick, like here where the Frat guided us to use phi plus and phi minus the transformation. So again, this is just math. There's not much to talk about. Just do the math. Okay. Very, very important. Now, the second thing is to remember Fourier transform. Fourier transform, you'll notice, I think only question 2 doesn't have it, and might have it sometime. Fourier transform is very important to learn for this test, and specifically the 2 notes that I said. Fourier, I might write Fourier wrong, I don't care. First of all, f of real. Remember the rule for real functions, it's very important. And second of all, remember the difference between phi pi. There's a minus in one of them in the exponent. I think those are the 2 main important rules for Fourier, but if you remember the rule for real function, you might as well remember the rule for imaginary function, which I'll let you figure it out for yourself.
What do you mean about the rule?
Rule for real function, if you do Fourier transform for real function, so phi of q equals phi minus q conjugated. This is the rule for real function. There's also a rule for imaginary function. Okay. And then, after the Fourier transform, you do equals 1 divided by square root of 2a, maybe times I don't remember. Square root of 8 and square root of 2. This is in order to transform it into the operator space. That's about it for question 1. Just do this term, the long, there's a lot of writing, and that's it. It's now question 2. How do I keep losing my erasers? Right. Question 2. Question 2 will always be a mean-field question. So let's do one question and then we'll talk about the rules for this question. Okay, first of all, we were given a Hamiltonian. Well, H0 equals sum over I, turn I, Ci dagger Ci, and so I equals epsilon 0 plus V minus 1 to the power of I, and H int equals U sum over I, Ci dagger, Ci plus 1 dagger, Ci plus 1, Ci. Alright. There's actually one more rule that I forgot to tell you, rule 0. Always summarize what a FRAT gives you. I didn't see it in this test, but there are tests where the question is like almost half a page long, and there's like 2 equations that you need to take out of it. So I always do what's comfortable for you, but I always just write all the details, all the important details on the paper, and then just think of it as a math question rather than a physics question. All right. So, okay. Oh yeah. U V. So this is 0. All right. In the part A, they give us epsilon f equals epsilon 0. Again, I don't care. Just some constants. And then the important part, d0 is equal by j c2j plus 1 and 0. This is the guess that they give us for the ground state. And the first question is using h0 to justify this state. Anyone wants to answer? Anyone wants to give it a crack why this is the ground state for h0? Thank you. Come on. Alright, when we talk about the ground state, we want to talk about minimum energy states. So let's imagine we don't have the interaction term for a second, and let's just look at h0. What will happen if we'll try to find h0 expectation value, which is the energy. Right? I don't think the energy is 0. Alright? So, what will happen? Let's say I have all the terms occupied. We see here that each term will give us an epsilon 0 addition to energy, so we can just ignore this epsilon 0 for a second, it won't change anything. And then some of the terms will give us plus V, which is a positive energy term, and some of them will give us a minus V, which is a negative energy term, since V is greater than 0. Now, if you want to take the minimum energy states, we will want only the negative addition for V. And we see that the negative addition for V comes for when I is odd. Or in short, when I is equal to some two whole numbers plus 1. So this G0 will give us only contribution on the negative V terms, or the odd terms of H0. So this is why the ground state solution, the ground state guess is this one. Right? So now that we explained it, we wrote it, they want us to show, to take the interaction term, do the Hartree-Fock approximation, and then to show that one of these, the Fock term, vanish. So I'll write one I. To find the Hartree-Fock approximation, I'm going to write just one of those, one term of this sum, I plus 1, I. And then I'm going to write some markings that will look like contractions, but note that they're not really contractions. They're just for me to simplify it. So first of all, we know that Hartree and Fock mean exchange term and self-interaction terms. More importantly, just remember the order. Hartree is last with last, and the two middle together. Fock is 1 and 3, 2 and 4.
Only when it's in normal order. Only when the interaction is in the normal order.
Yeah, okay. First of all, try to organize, if you get something messy, like if there was like n plus 1, try to organize it into a normal order-ish term. And note that if you replace these two interactions, for example, it's not symmetrical, it will also be okay. Just note the minuses. The minuses come from the need to move. Need to move the terms into place.
So it's as long as it's in normal order, so
you mainly need to care that the daggers on the left and the annihilation on the right, but you don't necessarily need to organize it symmetrically. It will be easier for you like to understand it by exchange term and self-interaction term if you organize it symmetrically, but the result will be the same. The most important thing is to remember the switch term. And then of course there's another term that we usually don't talk about, and it's not in this question, but I will mention it, which is the BCS term. I think it's supposed to have a name, but I tried to ask Efrat what's the actual name of it like 4 times,
So
and she kept like deflecting the question. So I don't know the name, so I'll just call it the BCS term, which is the
the Cooper term.
How do you know this?
I
Yeah,
heard
she
about
said
it.
it. Yeah.
She told you, but not me. Alright, so the Cooper terms are the creation with creation, annihilation with annihilation. But again, it's not here. It's actually even specifically said just the Hartree and Fock terms. But you should note it, and also last note about the Cooper terms. We see that this is a classical Fock state and the classical normal Fock classical. I mean, it's still a quantum state, but it's the normal Fock state. And the normal Fock state, the Cooper term will always be 0. So even if you think about putting them in your question,
For Fermi.
also for boson. So it's about the forgot the name. Autonormality of the states. That's why it's 0.
For the expectation values.
For the expectation value, yeah. Right. So I always start by writing the Hartree terms. So the Hartree terms. Too many markers. Alright, so there are 2 terms, Ci dagger, Ci plus 1, dagger, Ci plus 1, plus Ci plus 1, dagger, Ci plus 1, Ci. Okay, minus. Again, there's a minus here since we need to do one switch in order to get our term into place. We need to do one switch. one switch will give us a minus. Minus. This is a bad marker. Anyone? No, I don't have another blue marker. Oh no. Fine, I'm just writing it in black. You will imagine. Alright. Minus Ci dagger Ci plus 1. Ci plus 1 dagger Ci minus Ci plus 1 dagger Ci dagger Ci plus 1. Alright. So the front claim that the factor, exchange factor, vanish, and we can clearly see it, since again this is a normal Fock state, and we need that for this term right here, this term have the condition of orthonormality in each other. So again, creation annihilation working on the left is the same as an annihilation operator. So this will annihilate in position I, and this will annihilate in position I plus 1. And even if those two positions are occupied, this state right here will still be different than the state on the right. But of course, here there's also a simple solution that one of those, either I or I plus 1, has to be even, and we know that our even location are not occupied. So at least one of them will annihilate on an even location, which is annihilating on a vacuum. So again, so this is still 0. All right. Now we know that this term, this expectation value, will be 1 if I is odd, or if I plus 1 is odd. So I can write, I can specifically transform this expectation value, change the index from I plus 1 to I, and then I here to I minus 1. So I'll get Ci dagger Ci plus 1 dagger Ci plus 1 plus Ci minus 1 dagger Ci minus 1. Right? And then I'm going to put in Ci equals C2J. Sorry, I'm going to do actually a little bit different. I'm going to write it over half 1 plus minus 1 equals 1.
So this is only a...
Note that this is the same as writing a delta function for an odd, for an even, for an even I, which I moved times plus 1 dagger plus 1 minus 1 dagger plus 1. Right? Now, note that I can change the I in this entire sum, change this I, move it down by 1. So this will be minus 1 power of I, Ci minus 2, Ci minus 2, but Ci minus 2, just this term alone, I can move by 2 again. And moving I by 2 will not change the beginning here, so we'll just get 1 plus minus 1 power of I, Ci dagger Ci, and we see that the change in H, move back to black marker. U I specifically wrote it in a bit of a convoluted way without going into 2j plus 1 and stuff like that, because Efrat specifically asking the question to find how the term H0 changes or how the normal linear term changes. Okay. So again, this is how the usual question tool looks like. It will give you some basic ground state, and then you'll have to develop using it. And then, similar to this question in part B, they will give you more complex, or even won't give you at all the ground state, just give you the expectation values. So let's go directly to part B. Is there any question for part A?
יכול להסביר לי גם מה עשית שם? מה שכתבת באדום?
באדום?
ההזזה של האינדקס. מה ש-
This part?
כן.
כן.
Alright. So I wanted to simplify everything, so I'll just have some constant times the operators. So I wanted to make these two expectation values the same. So I moved this one by one. I moved this by one. Or the ones want this step.
And then why is it equal to half 1 plus?
Oh, this.
Yeah.
This, if you note, this is just a delta function for I equals odd number. This is a delta function.
Okay.
If I is an odd number, this will be 2 divided by 2. This is a delta I section J. Just a more complicated way to write it. And so technically, you could have just left the delta function, but I think this one looks pretty ill. It's so pretty. Right, part 2. Where was it? Okay, so part 2, we're given some general ground state. And we're given the expectation value for this ground state. First of all, CI W CI equals 1 over half plus delta minus 1 or I. And CI C2J is 1 divided C2J equals 1 over half divided 1 plus delta minus 1 above J. Okay. So we still need this Hartree Fock to solve this question. They want us to use this expectation value to solve the mean field approximation and eventually diagonalize the matrix, the Hamiltonian. So I'm just going to erase everything that's not relevant. Now, okay, and second. One. Yeah. Yep. And now actually we'll do it a little bit different. Since we know that there is a dependency on odd and even terms, I'm going to open this Hamiltonian where I to divide it to 2 terms, one where I is even, one where I is odd. On the odd eyes and on the even eyes. So I get int equals sum over j C2j dagger, C2j plus 1 dagger, 2j plus 1, C2j plus C2j plus 1 dagger, 2j plus 2 dagger, C2j plus 2, C2j plus 1. Right? One time I is even, one time I is odd. Now instead of 4 Hartley fork terms, I'll have 8, but it will be more organized. So I'm just going to write the Hartley fork term for the first one, and you can add yourself the Hartley fork term for the second one. C 2j plus 1 dagger, C2j plus 1 plus minus right? And then of course there's plus the Hartley fork of the second term. For time concerns, I'm not going to write it. Okay. And then you'll see why I explicitly wrote it like that, because then this term, it's very simple. It's just 1 plus delta. 1 over half. Right. I found another mistake in my notes. Cool. Very cool. Right? This one is 1 over half minus delta. And now let's just look at the term C2j dagger j plus 1. This one looks similar to this one, but it's the wrong order. But we know that we can take a conjugate out of this term, and suddenly we have the same form, just conjugated. It equals 1 over half conjugate 1 plus delta minus 1 j. Right. And of course, this term is just right. Oops, just right. You have a question?
No,
You have a question?
not on this exam.
You sure have a question? All right. Of course, this term we already know. Okay. Now, just a little note. I'm gonna line it so it won't confuse you. And there's a certain problem that I with this term. Let's write the fork term. This the second term here for a second. Now you see that this term is almost exactly the same as the expectation value given to us by Fat, but here the even term is higher than the odd term, where in the given relation it's lower. My guess is that Efrat meant to write that it meant just to say that it doesn't matter if there's a +2 here or not, but this is something that you need to, that I would ask Efrat during the test. I didn't find some way to manipulate it to like calculate this expectation value. If anyone has any suggestion, I'm open to hear. But I just think it's some oversight by Efrat. So Efrat also, like me, makes mistakes sometimes. And if you find yourself like terms like this, the first thing you should do is ask Efrat, and the second thing you should do is like solve them in the way that seems logical to you and write. And there's a problem here. This is what I think is right. Even if you're wrong, she'll give you most of the points. But you should ask Efrat. And I wanted to show this question precisely because I didn't figure out what she wanted this to be, and I took a guess. Okay, like I guess that this +2 doesn't matter anything. So take this solution with the parentheses there. All right. Now, after everything, all the calculation here, I'm just going to give you the final answer. The Hamiltonian under the Hartree-Fock approximation, given the expectation values and given my guess, is H equals sum over J epsilon 0 minus V plus 2U 1/2 plus delta C2J plus 1 dagger C2J plus 1 plus 0 plus V plus 2U 1/2 minus delta C2J dagger J minus 1/2 V conjugate 1 plus sigma minus 1 J 2J plus 1 double C2J minus 1/2 sigma 1 plus Okay. Now when we reach this form, we're halfway done. And we need to look at what form of matrix and vectors Efrat gave us, like pointed us to. So Efrat specifically told us she wants J dagger equal to C to J dagger C to J plus 1 dagger. Alright? And by looking at the vector and knowing that the solution for the matrix should be sum over J, J dagger H J. Right? We know what will be the order of the operators outputting from this equation. Here specifically, we'll get a simple conjugate first, then annihilation, creation first, then annihilation. But remember, in the BCS, we need to switch the order of some of the operators because if you remember in the BCS, one of them had the vector was creation annihilation, and then the annihilation of 2J plus 1 need to be on the left. So using the vector, you'll need to find out, using the vector given, you need to find out how to order your operators. It's a very important step. Luckily for us, we're okay in the orders, and we know how to find every term of this matrix. For example, the term in place 1, 1, if your matrix is A, B, C, D, the term A would be the term that comes before C2J dagger C2J. That is the first. So A here will be equal to this term, and so on and so forth. So let's just write the matrix over there. Where is?
So if you need to switch, you just use the commutators?
Yeah, just use the commutators, and again,
If you have leftovers?
say goodbye to the constants. I don't think anyone would ask you what is the overall energy with the constants and all of that stuff. As far as I'm aware, you can always, you can always throw away the constant in a Newtonian, but they won't come back to haunt you. Okay, so the matrix using this relation HF just be just be epsilon 0 plus V plus 2 U 1/2 minus delta minus 1/2 phi 1 plus J to U 1/2 plus delta. Okay, so we got to the solution that we want, and then we ask three things actually. We asked first of all to find the eigenvalues, basically the energy of our system. Second, we are given a known transformation, and we want to find all the constant in the question by this known transformation. So first of all, to find the expectation value, we just take the Miltonian matrix, reduce it by lambda I, take the determinant of this, and we try to solve for lambda. Lambda will be our energies. And what's the time? Let's see. 1.5. Okay, since everything takes a while here, know that for a matrix of the form A minus B conjugated C, for this matrix, lambda B A plus C plus minus square root A squared minus 2 AC plus C squared plus 4 epsilon value B squared divided by 2. I'm not gonna solve it explicitly. This is the answer. Just it's too long.
You also don't need to do it on the exam.
I'm pretty sure in my exam I wrote something like short like that and I got the point. But I can't guarantee your safety if you do this. I'm just doing it because we only have half of the tutorial in, and we're still in the second question. Okay. Then Fred asked to take this new solution, use a transformation gamma J minus dagger equals cos theta divided by 2 C2J dagger plus sinus theta divided by 2 C2J plus 1 dagger. Alright, and use this, and G equals pi J gamma J minus dagger. Use these two terms in order to find the constant in the expectation value, which I erased. Basically, you want to find phi here, and delta here, right? Using these two terms. So, how at least I reach this question? First of all, I'm trying to avoid opening the gamma here. Basically, I'll avoid doing this because you'll have an infinite multiplication of two terms. You'll get a huge Newton summation. It's not fun. Instead, I'd like to take, for example, Ci dagger Ci and transform the C's into gammas. So, yeah, okay. So, very similar to the BCS. I'm gonna do a lucky guess for the C to J dagger and C to J dagger plus 1 using the known relation of cosine squared plus sine squared equals 1 by taking C to J plus 1 dagger be equal cosinus theta divided by 2 gamma J minus dagger plus sine theta divided by 2 gamma J plus dagger. Right, and C to J dagger be equal to sinus theta divided by 2 gamma J minus dagger minus cosine theta divided by 2 gamma J plus dagger. Which again, note, this is in concept, it's very similar to what we did before when we tried to translate the field function into operators. I'm trying to generate some cross term, this minus q, that will cancel out and leave me only with the gamma J minus when I'll insert everything back in to the original equation. In my notebook, I also wrote an alternative approach to solving this question, but this is the better approach, just in general. But in the notes, there's another way to solve this. I mean, in the notes, both of the ways are written. Just mention another way to solve this. Okay, so let's just prove that this transformation is okay by putting it back into our original gamma. Gamma J minus dagger equals cosine theta divided by 2 of sine they mix up the term. Yeah, mix up the term. This one is the plus 1. And I should write here that I also mixed up the terms. Okay, so cosine theta divided by 2 gamma J minus dagger plus sine theta divided by 2 gamma J plus dagger plus sine theta divided by 2 sine theta divided by 2 gamma J minus dagger plus minus cosine theta divided by 2 gamma J plus dagger. Yeah. Okay, you'll note that cosine, sine, sine, cosine, so these two terms will cancel each other out. And then we'll have cosine squared plus sine squared. Again, it's equal gamma minus j. So the transformation is good. Now I build this transformation just from thinking about those cross terms. But you don't have to do this. You don't have to just build it from logic. You can build it by saying, okay, this transformation has some matrix transformation. Even though we're not given the second term, we can clearly see a beam splitter form, if you've ever seen one, a cosine sine matrix, and just find if the gamma equals u times u matrix times psi of c. Just try to find gamma minus 1. But using cosinus and sin and cosine and sine, you should remember the beams, what I call the beam splitter matrix, cosine theta divided by 2.
Son, it's not just the Bobliago transform that you wrote?
Again, you might be right. I'm not good with names. I give stuff my own name. I never remember the actual name, and I give them name based on what I use them for. And I do optics, so I use beam splitters. Yeah. So this is an important matrix. Remember, at least in my opinion, general. Okay. So now that we have this transformation right here, all these expectation values, for example, this one, become simple. All we need to do is to insert here this transformation, and we'll note that when I is even, only the cos term will remain, and when I is odd, only the sine term will remain. So C to J, dagger C to J equals to cosine squared theta divided by 2 equals equals 1 over half minus or plus, I forgot. Where is it? Plus delta, and C to J is 1 dagger C to J is 1 equals sine squared theta divided by 2 equals 1 minus cosine squared theta divided by 2 equals 1/2 minus delta. Of course, you can solve this. Will be theta equals cos 2 cos 1/2 plus delta. Again, you could probably write it more elegantly, but okay. Similarly, we can find the second relation, but again, time, so let's skip it. It will be exactly the same. Just input your new transformation inside this function. Okay, so that's question 2. So I'm going to ask you again: do you want a break, or do you want to do question 3 and then a break? Go everyone at once. You have until I finish to clean the board if you want to break. Alright, so let's take a 5-minute break, like 5 or 10 minute break. 7:50.
שר, תגיד, זה שאתה מוכר. מה עשית בסוף עם הזוגי לא זוגי? למה?
זה?
כן, למה?
מחקתי את זה קצת, אבל שים לב שהטרנספורמציה שבניתי ל-CI זוגי ו-CI אי זוגי. ואז לפי האם ה-C פה זוגי או אי זוגי, אני אציג משהו אחר בפנים. רגע, אני אבוא לך עם הטאבלט, שנייה.
כמה זמן?
עד 50.
10 דקות?
10 דקות.
50 זה 6 דקות.
6 דקות.
בסדר, אז 50 וקצת, ואני אדאג שלא אבחי לפני שהם אחרים, יבינו. לא.
אבל?
כן. כן. אז מה שעשיתי פה, רואה זה שני ג'יי, פשוט קצת מזה פנימה.
לא, אבל למה...
לא, מינוס פה?
לא, למה יש כאלה ששורדים ויש כאלה ששורדים?
שים איפה ה-G? רואה יש ה-G הזה כאן, אז רק האיברים האלה תורמים. אז גם ה-J פלוס לא קיים.
כי אין אותו פה, כי...
כן.
אוקיי.
ואז אם אתה עושה אופרטור הריסה, כלום זה אפס. מי שמבינים כן.
למה ב-2A ישר ניגשת למינפילד אם לא אמרו בכלל?
איפה כתבו? כן מבקשים פה, הנה.
זה ארטיפוקט.
Derived and expression of artifact. כן, זה מעצבן.
זה לא באמת ארטיפוקט.
טכנית, מינפילד זה כל השלושה איברים, אבל לפעמים משתמשת בארטיפוקט בשביל להגיד מינפילד, אז צריך לשים לב וצריך לזכור בראש שיש לך גם את האיבר.
מה ההבדל בין וויקס תיאורם? כאילו הבנתי שיש הבדל עם ה...
וויקס תיאורם זה דרך
אפשר למצוא גם הארטרי ופוק עם וויקס תיאורם?
טכנית וויק, אוקיי, שני דברים שונים. הארטיפוקט זה קירוב, של תנודות קטנות בעניין, וויק תיאורם זה דרך לחשב אקספקטיישן, שני דברים שונים. זו שיטה מהירה לחשב אקספקטיישן, אבל הסיבה ששמתי קווים בלוח זה בשביל לסמן עוד פעם מה האיברים הארטיים, מה האיברי הפוק, שיהיה ברור. שימו לב בדרך כלל אומרים ארטריפוק זה קירוב של ויברציות קטנות, זה לא כזה ברור. אני חושב שהדרך יותר פשוטה לחשוב על ארטריפוק זה קירוב של אלקטרון אחד פועל על אלקטרון אחר ואלקטרון אחד פועל על עצמו.
אז זה פרנטרט.
כן, זה כאילו לפרק תהליך מורכב של 4 אופרטורים שלא ברור מהו לשני תהליכים שאנחנו מכירים. תהליך של אינטראקציה ותהליך של עצמך, עם עצמך, כן פעם. האיברים האלה לא באמת חייבים להיות סימטריים.
הנה זה בדיוק. כאילו זה, כאילו תמיד כש-I שווה ל-I זה כאילו נשאר, וכש-I שונה מ-J זה...
רק שהמצב שלך פוקס בחוץ.
שוב.
אם נגיד, שימי לב שאנחנו כותבים את הפיתור המקוצר הזה, יש בעצם פה בין החץ הזה לאופרטור, יש לנו G, המצב שלו אנחנו פועלים. זה תלוי במצב. אם המצב הוא פוקס סטייט רגיל, אז לאורך כל האופרציה שנעשה לו, הוא יהיה חייב להישאר אורתוגונלי לעצמו. זאת אומרת שאם פה...
זה מה זה המצב פוקס? זה כשבדיוק פה...
פוקס זה
יצירה רק
שאת יכולה לכתוב שורה של 1, 0, 1, 2 כאלה. יש רק מספרים, כאילו רק אין 1 עם 2 עם 3 שונה לזה. נגיד ב-BCS ראינו שיש מצב מורבב של חור וזוגות. ואז בעצם זה לא פוקס סטייט רגיל, זה סופרפוזיציה של הרבה מצבים פוקס סטייט אחד על השני, וזה כבר פחות טריוויאלי להגיד שצריך להישאר אורתוגונלי ב-100%. אז פה זה פוקס סטייט רגיל וזה הכל פשוט שורה של 1, 0, 1, 0, 1, 0, 1, 0, נדע שאחד דבר שני נשאר אורתוגונלי, דבר שני חייב להישאר זוגיים, כל מיני כאלה.
כן, עוד שאלה. למה גם תתייחס לפחות ל-H ולא ל-H0?
ה-H0, שים לב שנכנס בסוף של דבר, אבל H0 הוא בצורה שאנחנו רוצים לקבל. זכור שכל הפואנטה של הארטריפוק וכל זה, זה שאנחנו לא יודעים לחשב אופרטורים בסדר רביעי, כאילו אינטרנלים בסדר רביעי, אנחנו לא יודעים איך להתייחס אליהם. פיזיקה זה מקצוע, שלא נעים להגיד את זה, אבל הוא קצת מקצוע טיפש, הוא יודע רק לעשות דברים ליניאריים, בעיקר, דברים ליניאריים. אז כל הפואנטה שלנו זה לקבל דברים ליניאריים, ב-H0 הוא כבר ליניארי. מקצוע טיפש של יכולות, שלא הרגו אותי.
שעה זה היום כבר?
עד 3, כי עכשיו אולי אני מתקוף אחרי זה, אמרתי שלא תרגול סטטיסטי.
יש תרגול ב4.
אני עושה, אולי אני אסלוג עוד קצת, 3.5 משהו כזה, אני לא רוצה...
לא, בסדר, זה כבר גם.
גם יום בזה.
כן. לסיים ב3.5 נשמע לי מבחינת אוכל. זה תורת. זוכרים לך?
חלוק אפשר להיות, אחד שאני... אמרתי לו שקראתי לו...
לא, ברור. כאילו אני מרגישה שיש הרבה חומר, אבל לא מספיק תרגול.
אני אגיד לך מה, השאלות פה ממש שונות מהשיעורי בית.
זה מה שהיא אמרה לי.
מה שונה? זה כאילו בשיעורי בית ציפיתי משהו אחר לגמרי. זה נגיד השאלה 2
אתם לא עשיתם לך תואר ראשון?
אני עשיתי מהנדסה. אז תואר ראשון פה שאני מהנדסה.
עם תואר ראשון פה, הוא לא היה.
מה?
ששיעורי בית משהו אחד, ואז...
כן, נכון, זה שונה לגמרי.
רגע, באיזה קורס?
נראה לי ברוב הקורס.
לכל הקורסים? כן? אני לא זוכרת את זה.
והרגשת ככה?
אני לא זוכרת. ברוב הקורסים בתואר ראשון בכלל לא הספקתי לעבור למבחנים. עברתי על הסיכומים, עברתי על התרגולים.
וואו, אני רק למבחנים.
כן? טוב, אני צריכה את העקרונות לסדר עם זה. אבל עכשיו אני לא מספיקה לעבור למבחנים, זה דפוק.
ואת חייבת לעבור.
אני חייבת.
חייבת.
היום בערב, מחר ומחרתיים.
תראי, מבחן ראשון תחטפי שוק. תראי כמה זה שונה מהשיעורי בית. רק שאלה 3 אולי טיפה דומה משהו.
אבל מה שהיה בהרצאה האחרונה, גם עם הערובות האוטונומיות, קצת בלבל אותי, אחרי שעשיתי טוב בתרגילים על האינטגרלים גאוסיאנים, פתאום זה...
כאילו הקטע שם זה לסדר את הדברים שזה ייראה כמו הגאוסיאן. ואז תוכל לפתור את זה ישר.
כן, אבל היא פשוט זרקה לנו, כאילו איך...
כן, כי בשיעורי בית 5 עשיתי ו-6. צריכה להוכיח את זה פשוט. 5 עשיתי 5 ו-6
5 עשיתי, 6 עשיתי לכל חצי שעה אחת.
עשיתי את שאלה, מה יש עשיתי? זה כמו מבחן, זאת שאלה מבחן.
כן, אז
זה דומה למבחן.
הוא גם כותב שם, רק שימו לב, כאילו באופן מסורתי, יש שאלה לא באסטרונומית, במבחן.
זה רשום שם שיעורי בית?
זה היה רע, כן. אבל זה, אני צריכה לעשות.
נראה לי זה כן, זאת שאלה שלי.
עשית את זה?
נראה לי שכן, זאת שאלה שלי.
קיצר, אבל זה שיש עכשיו, הוא העלה פתרונות למבחנים, נכון? לא מודעים? אני זה אני מקווה שיש. אולי זה יחסוך לי קצת זמן.
גם כזה, היית אומר.
אני ששמתי עליי, אני מת. אמור. בסדר, שאני איפה אני עובד יותר טוב.
אני מביא במבחן שישייה כזאת.
תביא, שוקולד. שוקולד זה ממש טוב המבחן, זה טיפ. זה הרבה הורמונים טובים.
המבחן באמת 4 שעות?
4 שעות, כן. 4 שעות, 3 שאלות. באמת, רוב הזמן זה פשוט לכתוב מהר. צריך לכתוב.
כן, אתה מסודר.
אני גם אחזור על זה עוד כמו שכולם יהיו פה, אבל זה הטיפ הכי חשוב, זה פשוט לכתוב. גם אם אתם לא יודעים מה קורה, תכתבו את הסדר, תפרטו את כל האיברים, אפילו אם צריך. עשו אקסטרה. פשוט לא לחכות, לא לעמוד ולחכות.
עכשיו שולח לך, שיר נפשך חלק מסמך שהוא לא גמור.
שנייה, 2, לפעמים.
מישהו בדיוק אמר שם מבחנים לא מזכירים את השיעורי בית.
בגלל אני רק על המבחנים.
הצפתי על הכם.
אמרתי בסטטיסטיק צריך... האמת לא הגשתי את הגיל האחרון. כאילו אמרתי אני לא אגיש אותו.
האמת שהוא ממש פשוט.
לא, בטוח פשוט, אבל הרישיון שלי במטלב נמחק.
אוי? למה? את יכולה לדעת כל היום?
לחדש וזה כן.
זה שטויות?
צריכה לחדש לעשות.
אתה יכול לעשות את זה
את יכולה לעשות את זה
בכל
בתקופות אחרות, כן.
כל כן, רציתי, לא משנה, לא הספקתי. אמרתי יאללה, כמה זה כבר מהר, כאילו. עשיתי סיכום הרצאות אם אתם רוצים שאני אשלח
בוודאי בקורס.
בזה.
אני
לא יודעת אם זה יעזור בכלל.
לקחת את מבחנים של 2018.
אוקיי.
קראתי רק 23, 21.
אבל 23 זה...
סליחה, לא 23, סליחה.
Okay,
21.
so let's do just a little summation for question 2, and then we'll try to do two different question 3 questions, because I think this subject is had the least work on it during the classes. It's also the most recent one, no exercise on it. So I'll do two questions for question 3. First of all, summation for question 2 is like so. Divide your Hamiltonian to H0, which is the linear term, which we usually don't care about in the question 2, and the interaction term, which has 4 operators in it, and you need to. And the first thing you need to do is organize this operator into a normal order, where the creation operator is on the left, the annihilation on the right, and then you write directly the Hartree Fock term, and maybe the Cooper term if it's available, if it's not non-zero. You can and probably should use, if you not fully trust yourself, my notation with the lines. I think it make the entire Hartree-Fock approximation much simpler to visualize, and it will also help you remember what the minus comes. Okay, and then the next step will be to directly calculate the expectation value either by a given result, like in part B of this question, or by directly calculating it yourself, like we did in part A of the question that we did on the board. After that, you try to organize the Hartree-Fock approximation result into a matrix. The matrix and the vector should be, and the operators at the end, should be ordered by the vector hinted to you by a frat. Part of a given vector, and you need to check that the vector matrix vector multiplication will result in the same Hamiltonian as you input to your question. And after that, you basically mostly only focus on the matrix term of the Hamiltonian, which you should diagonalize. After you diagonalize it, you will immediately get your solution Hamiltonian, and using the transformation. And you can, there are multiple different ways. I'm not going to go into linear algebra on how to solve, how to diagonalize a matrix, and how to transform your states. That's about it. I think it's the most technical of the three questions. And this question is especially, and in general the entire test, the most important rule is just keep writing. You have 4 hours for 3 questions. 3 questions shouldn't take you 4 hours, but there's a lot of writing. So even if you're not completely sure what you're doing, just write, organize all the data, all the steps, and eventually you'll see where you should go next by having all of your data organized. And I think it especially goes for question 2. Now, moving on to question 3, I think it's the most simple question in principle, even though it's the scariest looking question. Because as I talked about in the tutorial, we are dealing with integral over functions instead of integrals over space. And it's something that seems non-trivial, but in the end, it has a very simple solution. So instead of going on and on about question 3 blindly, let's just do a question, and then we'll talk about it, and then do another question, if we'll manage. Okay, so question 3, the same test, 22A, we're given, as you can see, this is a question that the frat likes to talk on and on about the physics of the question, but we're going to ignore. We have a field. Am I with that? Well, we have a field psi. Yep. Which is a complex field. This question is very important to note the complex and real field. And then we have field phi, which is also a complex field this time. All right. Okay. Now, why is it important? Again, we see it in the partition function. Z equals the sine conjugate phi e minus s Now again, you don't need to be worried about this capital D's. This basically means take every point in space and integrate over all the possible values of phi. But you won't do it explicitly. This question assumes that you did homework 5, question 1. That's the entire solution of the question, but we'll get them. First of all, let's just write, that's S. S equals S0 plus S dm. dark matter plus delta S right, where S dark matter equal beta.
What's the initials, DM?
Dark matter.
Dark matter.
Yeah. Again, if not specifically really likes dark matter, I see like a million dark matter question, but the physics is not is secondary.
Okay.
Right. The conjugated d tau phi plus j gradient of phi plus m squared phi value squared. And then right here delta S equals g d tau d r rho phi plus phi conjugated where rho equals phi and j greater than 0 and g and m are constant. Nothing's given. Right. This question, like the first question, usually starts with Fourier transform, which is exactly what they ask of us. So they want us to use the Fourier terms phi of q and rho of q. So we define. We of course do it orderly in the test. Yes, like phi of q is the I, q vector, r vector, and tau, which again, q without a vector encompass both the q vector and omega n in it. Okay, and rho equal sum of the q, rho q e I q r minus omega n tau. Okay. Now let's take, for example, this term, do the Fourier transform of it. Then I'll assume you can do the other two, and I'll also do this term, because this the second term that I'm noting is very important. Let's do the first term, try to do the Fourier transform of it. And if you want the full answer, you have it in the notes in the Lemida website, in the Moodle. The R, sum over Q, phi, Q, conjugate, I minus I, omega n tau, phi q tau, e, the I, q tau minus q, r minus omega n tau, n of tau. Okay, again, taking the integral all the way inside, putting it here. This exponent in integral will just give us a delta function, and this time q tau equals q. We'll have equal minus I omega n, the sum over q, minus I omega n, so the value phi q squared. Alright. Now yeah. Okay, now for the second term right here, rho integral the tau ddr for delta delta s, yeah, dr rho phi plus phi conjugated equals d tau R, sum over Q tag, of row Q e to the I Q vector, row vector minus n tau, phi Q tag e to the I Q R minus n tau plus phi to the Q tag conjugated e to the minus I Q R minus omega n tau. Okay. Now we see here we have two different delta functions. One of them will give us these two together will give us delta q psic minus q tag, and these two together give us delta q tag. I'm going to choose specifically to take the minus in the top part on our O function, on our O. Specifically, I'm going to write the result, then I'm going to explain why, equals sum over Q, O, rho Q, plus rho minus Q. I want, in the end of all this complicated messed up stuff, I want to get an equation. Let's see if I copied it in my note. No, but if you look at exercise 5, question 1, I'm pretty sure it's equation 7. This is just from the top of my head. But in the end, you want to get into a term. It looks like this. V dagger A, V plus this is minus. You should know this integral by heart. It's just a Gaussian integral, and we have the solution for it in the homework notebook, in the homework assignment. Not even in the homework solution, it's just given in the homework assignment. So, to keep it in V and the V dagger, I elected to put the minus on the row to keep it organized. And then the row would just be like omega dagger. Okay. So after doing the Fourier transform for all 4 terms, 1, 2, 3, 4, yep, we get SDM equals sum over Q of V Q value squared over N J to value Q squared plus M squared. If you're really stressed on time, honestly, I will just remember the transform Fourier of this by heart. It's not that complicated. I think you can if you do enough Fourier transform, you know how to do this in your head even without remembering them. But it will save time. Delta S be equal to G over Q O minus Q Q plus O Q V. This is part A. Very, very simple. And again, the point of the Fourier transform is to bring you to a linear state with no extra operation like derivatives and stuff like that. Just linear state and some constants. Now, they want us, Frat wants us to do the integral over the phi function and to get the result. So again, we use this equation. When you note that vector time matrix time vector will just give us the sum, and because we have a single sum here and not a double sum with two different indexes, we know that this term will give us a diagonal matrix. So let me just write the entire as a partition function. Just to make it organized. Note that I replace the terms that are being integrated with the Fourier terms. It's perfectly legal. E to the minus S0, E to the minus over Q, absolute volume Q squared, minus I omega N J Q squared plus M squared plus rho minus Q Q plus rho Q conjugated G here, and I'll put a minus somewhere. One second. Forgot a constant in my notes. Just wanted to write for later, so I can upload the correct. All right, now this one you already know. Just the solution for this integral equals times pi power of n, where n is the number of q's here, and then multiply over all q's, that's I, n plus j value q squared plus m squared, E minus Q O minus Q O Q G squared divided by minus I omega n plus J Q absolute value squared plus M squared. This I just got from an equation. I didn't do any math myself here, so it's just in your home. And I see I didn't write this step in my notes, but I will add it. Forgot the name.
Green function.
Green function. The denominator we already saw the solution for this in the tutorial notes, but I seem to forgot to add it. Also, I don't think it's very important to open this function for the solution. But anyway, we see here the question asks us to find the S effective. It will be. I'm going to write it in some place so everyone can see. The question asks us to find its effective equals sum over Q, V of Q, OQ minus. Might be, no, it's the correct order. Which is again another reason why I choose to take this form, the solution for the Fourier transform. Now we can see that VQ, simply see that VQ equals G squared divided by minus I omega n plus G Q to the value squared plus M squared. That's it. Okay. Now for part C. We are given that in a very, very high temperature, the only term in the Metsubaru sum is when omega is equal to 0. Omega n, where n is equal to 0, and we know that omega n equal 2 pi beta n divided by beta. Right? Thank you. Because it's very weird, we use beta for time and t for the one divided over time. I don't like it. So 2 pi divided by beta n. So again, if we only have the term where n equals 0, then we can just take omega n to be equal to 0. So Q will equal V squared divided by G. Did I invent a constant? J. Oh, sorry. J. J squared plus M squared. And question simply asks of us what is VR in this case. Alright? So to find VR, we just need to do the reverse Fourier transform. V R equals 1 G squared divided by J integral dq E I Q x divided by Q squared plus M squared divided by J. Note that I remove the J to the outside and the G to be left inside the integral for the form of the hint that we're given. We're given the hint e to the I x divided by x squared e squared p dp equals dx equals pi divided by a e to the minus pa. So just using the hint out here, we get g squared divided by g divided by j times pi divided by e squared, so it's m divided by square root of j times e to of r minus this one value r times m square m divided by square root of j. Okay. And now the last thing that they asked of us is to find the decay length. Well, decay length, you just take in the index to change the variable and find the index that's attached to it and take 1 over it. So lambda equals square root of j divided by m. That was the entire question. Let's see.
רגע, שאלה איך זה קשור לדארק מאטר.
I don't know, you tell me.
לא, היא שאלה את זה.
What? She asked this?
באמת?
כן, לא שמע. How it's related to dark matter mass.
Oh, yeah. It goes like 1 over the dark matter mass. Yeah, don't, when she asks stuff like that, don't try to look for some physical explanation. Just try to look for a mathematical one. It's enough. Anyway, question 3. Very quick, very short. Question 3 is 2 steps. You need to remember 2 steps. First, you do Fourier transform. Do Fourier transform to get to a linear form, so you won't have all these annoying derivatives, which is an operator that we don't really know how to integrate over each other. So Fourier transform, and then the second step and the best step, open your homework and look at it at question 5 from homework. Question 1 from homework 5. This is the 2 step of question 3. That's it. Remember that the equation in exercise 5, equation 5, are also applicable when you integrate over a function. This equation only describes a form of an integral, a Gaussian integral, not exactly dependent on what your variables are. That's it. The only thing that you might need to look for is if your variables are real or imaginary, but usually it won't really change because I write pi over n and I don't really say what n is. And if it's real, you have half the function to integrate over, so it will be n divided by 2, but I can just call n divided by 2 and not tell anymore. That's it. Yeah, that's question 3. That's 2 steps. So let's do another question 3. The choices are question 3 from 22b or question 3 from 24a, b, or c. Your pick. What do you say? If anyone has the tests here and has a question that he has a problem with, now it's the time. If not, I'll just pick at random because I don't remember.
Just pick.
Alright, I'll just pick at random. And we'll do, I don't know, 24a. Second.
סתם, נראה לי שאלות 2, מה הכי קשה?
You want to do question 2? Again, this is your time, not my time. This is your time. You make the choices. So I'll erase the board. You, I don't know, convene between yourself, decide what you want to see. You have like a minute to choose.
Do you remember the question 3 for fermion?
Question 3 for fermions. I never saw question 3 for fermions in the tests.
So that means that you're
But I don't have one ready.
giving up information.
I'm withholding information. I don't think I ever saw someone do question 3 for fermions, but it will be, honestly, it will be almost exactly the same. Just the Gaussian integral solution we'll take from the tutorials. The tutorials will solve them with a fermion. And if we have fermion, you need to notice when you switch the variables, there's a minus added. That's the 2 main differences. So while I don't have any prepared, I honestly have never seen someone ask about it. Technically, you should look out for it and just know to go to the tutorial instead of your homework when you do it with fermions. So question 3, 2004a. We have a very, very beautiful explanation for a bosonic atom and whatever, which I'm just going to ignore. Right field. We're given 2 fields. This time we have a real field, which is a real function, and a complex field. Right, and again a partition function.
זה עכשיו 24 של 3?
24A. 24. Will S equals S0 S phi plus SC, where S phi equals integral 0 beta tau While I'm writing it, I'm going to remind everyone that technically, when you do Fourier transform and all of this stuff, there's a normalization factor, and I hate it, and I won't acknowledge it. I refuse. You can't make me. Squared again. And then there's mixed term. Oh, there's one more thing to remember in this question, which I'll tell you after this question if we not see it here explicitly. There's one more trick that will come in the end of this question. I will explain in the end of the question. Okay, so we're given this entire partition function. This is the actions, and they want us to represent this function in the Fourier space, where we consider psi conjugate times psi to be equals rho. And then the front asks us to represent this function with a phi of q and rho of q. And then, what I wanted to show is in this question. So we want to Fourier transform these two actions, and then we want to find rho q, the representation of rho q using psi q. That's the first question. That's the first part of the question. Okay. So again, I'll do one, and then you can do the rest. Tau x of tau phi squared equals tau x on q tag minus I omega n minus I omega n tag. So I have the derivatives here. Phi q tag e to the I q plus q tag vector. Technically it's not a vector since there's only one dimension, minus omega n tag tau. This is a delta function, q tag. So it's equal to right, minus. Correct? Correct. So we have omega n squared, since minus times minus is plus, I times I is minus, then q minus q, so it will add another minus. So at the end we have a plus, phi q phi minus q phi q. Again, cool trick. Phi is real, so it's conjugate symmetrical, or whatever it's called. Equals sum omega n squared absolute value phi q squared. Okay. And notice, I'm not going to write it explicitly, but notice that rho here is equal to the absolute value squared of psi, so it's also a real function. And phi here is a real function, so we can do the exact same trick, but I'll wait. I'm gonna open this up as where is it? Where do I write this? I'm gonna open this up as 2k Notice I only got one of this term when I'll do the Fourier transform, but then I'll split it in half. For example, let's take this term, just this term, and see how we get those two terms from it. So OQ or phi Q conjugate equals 1 over half OQ phi Q conjugate plus OQ phi Q conjugate. And then what I'll do is I'll replace the counting order on one of them, minus, minus. And then, because those two functions are real, I can remove the minus and add a conjugate. So I'll remove the minuses and add a conjugate. And then from one term, I got term n plus its conjugate. Why did I do that? Anyone has a guess?
You want to use the formula.
Yeah, I want to use the formula, so I'll do whatever tricks I can, whatever tricks I have up my sleeve to get an equation that's similar to the formula. Okay. So this is one answer, and the other solution will come from this plus the transformation of the x, which again I'll spare you the ink and time. Now the last thing that we need to find is we need to find phi q of psi q, rho q, sorry, of psi q. How to represent this like so. For this we're gonna do what I like to call double Fourier transform. We're gonna start with phi q and say, okay, phi q is basically the reverse. We can open it in the reverse Fourier notation of rho x strict tau e minus I xk minus omega nt. Right? This is just the reverse Fourier transform. Notice the minus here, since it's the other way around, it's the other direction. And then I can insert in this row psi absolute value squared, or dx d tau psi conjugate psi e minus I k x xk whatever tau.
It's supposed to be K, right? Q instead of K. Like just
I wrote this solution like a year ago, and back then I used K, and now I use Q.
Okay.
So it's the same.
It's just the same. Okay.
Yeah. Actually, I would prefer you use K here, since we use Q for the summation that includes the omega. So K is probably better, which is why I stick with K here. Okay. So now I can take this equation and insert here the Fourier series of psi itself. So it's equal to dx d tau sum over q tag. Actually, it's q tag, since we already have a q here. Q tag, q2 tags. Where is it? Yeah, right. Q tag, conjugate, Q tag. In my note, I wrote the two tags on the conjugate just so it will be nicer. Again, it's arbitrary. Which one I call Q, which one I call tag, which one I call two tags. And then just sum up all the exponents. This one, the exponent coming from here. So it's I k tag minus k2 tag minus k x minus omega n tag minus omega n2 tag minus omega n of tau. Okay, again, you can take this integral all the way to the exponent. This one will give us delta q tag sig q 2 tags plus q. Right? Then rho of q will just be simply sum over q tag rho q tag conjugate rho q tag plus q. I just put here, instead of q tag, I put here q double tag plus q, then change the double tag to one tag. That's it. So the big trick is just simply, as I said before, do a double Fourier transform. Take the term in the Fourier space, move it into real space, where you know how to insert it, right here, and then transform it back into K space, Q space. That's part A of the question. Okay. Now for part B, they tell us, okay, you found all the transformation in part A. Now do an integral over phi and find the action based on psi, which is what remains. It should be dependent on rho q and rho minus q. And find, I'm just going to write it instead of going on and on and on and on and on. B, integrate over q, find s int equals sum over q dq rho q minus q. That's the first part of the question. We'll handle this, then we'll handle the second part of the question. B. Okay, the partition function after everything. Integral d psi q. So q. Capital D, sorry. D. D. Oh. 0 e minus over q n squared divided by u plus u k squared phi q absolute value squared plus I lambda k divided by 2 rho q conjugate plus rho q conjugate for q and using the equation from your homework we'll get equals q conjugate for q of n and omega n squared divided by u e to the minus sum over q lambda squared k squared divided by 4 uk squared 4 I don't think there should be 4 here, but I'm mistaken.
Why not? It's coming from the...
Oh, from the 2 here.
Yes.
Oh, sorry. It's an old solution, and I don't trust myself, to be honest. Rho Q absolute value squared. But again, notice we want to get to rho Q, rho minus Q, but it's exactly the same as rho absolute value squared, since rho is a real function, and we know that this term is equal to rho Q conjugate or equal to absolute value rho Q squared. So again, this is VQ. Okay. So this was the first part. I'm just going to write the solution on the other side here. Right, then V of Q equals minus lambda squared K squared divided by 4 U K squared plus omega N squared divided by U. Alright. Then we are told that for a sufficiently high temperature, the Mitsubara sum, right here, is dominated by omega n, where n equals 0, or again omega n equals 0, and we see that V cubed t goes to infinity will just be equal to lambda squared divided by 4 u. Right? Okay. This, and they want us to take this interaction, the interaction action here, and transform it back into real space. So then E of sum over Q of, I'm gonna just call, since the constant, I'm gonna call it V0, absolute value rho Q squared. We want to transform this back, but we already know, you should already know the transformation of some function absolute value squared. It will just be the transformation, it will just be E, the integral tau dx of V0 times rho absolute value squared, or E, the integral tau x V0 absolute value psi to the power of 4th, which is exactly what we're asked to find in the question. Yep, that's it. And I don't think we have time for another question, but you can try if you really want to. If not, then all the questions are all the questions are in the website, all the tests are in the website, or with all the solution. And if you have any question, text me. This is the week when I'm 100% available for your question. I honestly didn't make any plans for this week, so spam me with questions. Just honestly, just bomb my inbox. Just do it. I don't care. And I'll be here to answer whatever question you have. And especially if you find a mistake in my solutions, because I'm a silly guy and sometimes I miss the divided by 2 or minus, stuff like that. Sometimes I'm a little bit silly. So just, if you find a mistake, let me know. It will be good for you and for everyone else in this course. That's it. I think we're done since we don't have time for another question. No problem. Oh, No, we wrote a summary. We talked about how to solve equation 3 like in summary, right? Fourier homework equation or tutorial equation. Homework for boson, tutorial for fermions. Right. I mean,
זה
אז אתה?
זה רק
יש לך
הגיבור.
שאלה.
כן.
זה אותו מבחן 2024 א',
Right.
עכשיו תנאים בעניין, אם אתה זוכר.
בואו נעשה את זה השולחן. למה אנחנו עושים דבר מידע?
יש פה את הנתוניה, נגדיל בסיום, ואז יש פה את הקירוב מינפיל צריך לעשות את זה. אוקיי, ושנתון הערכים האלה אז הפתרון שלך זה הקירוב של ה-V ואפרת נתנה את זה